Hello, everyone, and welcome. Wow, it's 2025. We are looking at the first month, the 8th day, and the crew is assembled. And we're going to do something a little bit unique today. In the past, we're bringing back the past first off. We have Mike Kelly, our staff geologist, or I should say our resident geologist. We don't pay him. So, our resident geologist or a crew geologist is going to bring back one of the great things about our channel, which is the Meteorite 101. This is a series where we dig deep into one topic. We usually dedicate an entire show, which is a 45-minute episode, to that one topic. But to be honest with you, this doesn't need that much, and we just want to hit high level. We want to keep it a short video, so hopefully you guys appreciate this. We are going to be solving a mystery. So as I said, Mike Kelly is going to be taking us through a 101 session, Meteorite 101 class, if you will. And today we're going to be digging into the mystery of XRF and XRD. Now, these are scientific instruments. He's going to tell us all about it, so don't worry. These are scientific instruments that give you some type of information about the composition of a sample you're looking at. So what I wanted to do first is show you, because sometimes it's hard to understand when we're talking about things without seeing it and picturing it first. So right now I have two videos. These are from Tucson, I think just a few years ago. One of them is Blaine Reed, who is a master at deciphering the information from these machines, which Mike will tell you is very important. So we brought him a sample. It was a sample we found on the ground outside a meteorite dealer's place. And he said, wow, that looks like my braconite. And we brought it to Blaine Reed just to make sure before we threw it away. And this is the video.
This is terrestrial. Terrestrial? Yeah, it's terrestrial.
What makes you say that? I mean, what
the
readings?
iron content's way too high. The chromium content doesn't exist. I mean, it's got nickel in it, but yeah, I mean, I should be seeing like 0.4, 0.5% chromium. The iron content should be down around 18%. Titanium's too high. Yeah, so I don't even need to waste time going to the second beam. This is terrestrial. This I'm certain.
Yeah. So this is the potential braconite that is no longer potential. It is just a earth rock. But yeah, this is one that we found outside of Adam Aronson's, and he thought it, and we thought it may be a braconite that someone was in some stage of stealing. Yeah, let me see the real one. Okay, so this is the real braconite.
I mean, I was looking at the two end of the scope last night, and I'm like,
All right, so once again, we have science teaching us and telling us exactly what we need to do. So thank you, Blaine Reed. Appreciate your help.
So that's an example where we found a rock outside a meteorite dealer's store, nicely tucked away behind a bush, and we thought, wow, someone's trying to steal this. We brought it to him. He says, yeah, that looks like my meteorite. So we cut a portion off, got it tested, and you see immediately when Blaine Reed started reading his data, he knew immediately it was a terrestrial. So that superpower is gonna be what we get into today. Here's another example of an XRF machine, and this is in the Meteorite Mansion featuring our own Pat Brown.
So what we have here is my potential lunar that I found in an NWA bin, and Pat is putting it on. This is the other half. We cut it last night. Matt Stream and I cut it last night, and it looks really good for potential lunar. So we're gonna run it. Pat's gonna run it through Dustin's XRF, and we're gonna see what kind of results we get. See if it's worth going back and digging through the case for a bunch more. I'm pretty excited about this because this is the first real candidate and first real need of the machine that we're using. And I've never picked out a lunar from an NWA pile before. So not gonna get all rockhoundy-itis on it, but I'm pretty excited.
By the way, this was not a lunar.
I didn't completely cover the window, but
No, I don't know how good the audio content is for the rest of the video, and I don't know what else is going to be said, but this gives you at least an idea of two types of XFR machines and the data that you get off of it. This is obviously a really nice one, but now I think we're just going to turn it right over into Mike Kelly for our lesson of Meteorite 101, focused on these two technologies and machines. Mike, please educate us, if you will.
Good evening. Sure. Yeah. So you had mentioned XRF and XRD. So on this slide, I cover both of those. So XRF is X-ray fluorescence. And the thing to know there, both of those machines in the videos you just saw were XRF, right? One's a handheld, one is kind of a benchtop. Obviously, the benchtop's a little higher end, gets a little better results. But what you want to know between XRF and XRD is XRF is simpler, faster, cheaper, and what it's telling you is it's telling you the elemental compositions inside of the material, but it's not telling you how those elements are related to each other, right? XRD is X-ray diffraction. That's more expensive, right? Those are basically lab machines. And the major difference is it's going to take a longer sample test, and it's going to tell you how the elements are arranged into structures. So basically, it's going to tell you what minerals are in there, right? I arrange the elements, I make minerals, and so it's going to give you a little more data. Again, that's kind of out of the reach of the average collector or most places you're going to go to, because they are more expensive machines.
Just to clarify or do that, beat that against the wall one more time for me, because I didn't understand this when I was looking at the slide earlier. The XRF is going to give you composition, but it's not going to break it down and say that those atoms are aligned a certain way to make a mineral of X, Y, and Z. It's going to give you the element, but not the mineral.
Yes, exactly.
Okay, thank you very much.
Okay, so common places that you find XRF, and you'll get people presenting readings a lot of times. You'll see them in pawn shops, and they're there because pawn shops want to be able to differentiate rings that are gold, what percentage gold it is, or tell if it's fake. So again, they're going to have machines that are set up, and their focus is going to be to set those machines so that they're reading precious metals. So the thing to note about those type of shops, some of those machines, in order to save money on the machines they're buying, they're set up only to do that. So they won't even do what we want to do as meteorite collectors, to figure out what's in the sample the right way. Same thing, you'll see those type of machines a lot of times at metal recyclers. Again, they're not so much focused on precious metals, but they're focused on metals in general. And again, they might have bought themselves a machine that caters to their need. And so if you take anything else to them that's a rock and has light elements in there that most rocks are made out of, if their machine is not set up to read it, you're going to get false readings. The final group that you'll typically see these machines at are either mineral folks or meteorite folks that are very interested in doing their own compositions, in addition to research labs. That can be assay labs where they do it commercially for pay, or it could be at university material research labs where they're interested in doing research on materials and figuring out what different things are made out of. Again, a lot of times, especially for the minerals or meteorite folks, they're going to have a machine that they know can test minerals and is set up to the right parameters in the machine to get the right readings, so you're less likely to get false readings. Again, because they purchased the proper device and they know how to set it up in order to use it.
Mike, let's expand on that false reading thing. If this is an accurate device, how are we going to get a false reading of 3% gold in my sample?
Certainly. So what the device is doing is it's sending a primary X-ray beam at the sample, and then it's exciting the sample, and secondary X-rays are being produced by the material. The device then has sensors that read those secondary samples and run them through different spectra that they're looking for, and they're looking for peaks at different points in the energy spectra, right? Now, what can happen is multiple light elements might give peaks that overlap each other, and in combination, right, those overlapping secondary readings will be a false positive for what the machine's looking for. So if I stack up the right set of minerals in there, right, I might get a reading that looks like gold, right? Just because, not that the machine is looking for only gold and only looking for heavy metals like that, and in all reality, what you have is light, non-metal elements producing peaks that overlap each other that combine together give you a false reading.
Thank you very much. And to touch on the first one once again, the pawn shops and metal recyclers, I guess we'll throw them in. They're buying specific instruments for what they need. You can probably buy a wider bandwidth, if you will, and spend a lot of money. But pawn shops and metal recyclers are probably working on pretty thin margins, and they're going to buy the cheapest quality device in their bandwidth. And that's why you have it broken out in the bottom. The mineral and meteorite people, they're buying the full bandwidth. They're observing everything, the lighter materials and the heavier metals.
Correct. And the interesting thing, Topher, is you mentioned that, like if you look at a handheld machine, like in the first video, some of those companies, they use the same outer frame for all of their handheld machines. They change the color based on the model. And literally because it's a better sensor that they put in there or better software they put in to read and analyze it, the machine may look the same and just be a different color, but it's a much different capacity than the model of a different color.
Thank you.
So just the way the machines work, and you kind of saw, especially in the second video with the benchtop machine, you saw kind of reading how long it was operating at one point in the video. So the longer you let it read a sample, the better your data is going to be, right? So that comes with a trade-off, right? Longer read times means you're putting more usage on the X-ray generator, basically X-ray source in there, right? So you're going to burn through that source faster, the longer you spend on each sample. But again, if you can get a longer sample count, you'll get a better reading. And the other thing that we talk about a lot is what you're trying to really read is bulk composition of the material. So bulk composition is if I made it completely homogeneous. These machines can't make the material completely homogeneous, right? You haven't broken down that material. So basically what they're doing is to try to get around that is they're taking multiple point readings, right? And the more points you read off of, the better your bulk or closer to bulk you are, but you're never true bulk. If you were looking kind of for true bulk, the thing to do is to powder the sample, which is a lot of times we're trying to analyze the sample without doing any damage to it. So that's not the route to go. But in labs, typically, you know, if you're sending a sample to a lab that's focused on being highly accurate, what they're going to say is, give me 5 grams and I'm going to powder it. And then I'm going to use either the powder and acid wash it, or I'm going to powder it and then melt it into a uniform glass and read that. And then I'm getting true bulk composition.
Perfect. Yeah, because it's all now been homogenized in the one thing rather than going around taking more and more samples. You would have to cover a lot more samples to get that accurate of a result. How many points are usually collected of data when it's not a pulverized sample? Do you know?
I don't know offhand. And again, a lot of that is also the read time. You know,
Yeah.
because like I said, each machine will give you an option on how long you want to read to. So again, like you heard with Blaine, you know, hey, I'm not even going to take a second shot at this thing.
Yeah.
I know using Dustin's machine, it was critical to use the shortest amount of time to get the assessment you wanted. So we weren't putting excess life on the X-ray source.
Yeah, because they're expensive machines and we were using it for free. So okay, so now we have the right machine. We spent all the money to get the right one. We have it set up perfectly. What exactly are we looking for?
So if you break things down, what I got listed out here, these are the common elements that form minerals in rocks, whether they be earth rocks or meteorite rocks. So these are all of the things we are looking for as far as the main elements. So if you're not seeing this list of elements, if you're seeing, like you said, all gold, all platinum, all heavy metals, none of the things like silicon, or even some of the other light ones, which we'll see in some of the other readings, then you're probably set in the wrong mode. So some of the general facts, and we'll check out one of the readings off of one of the machines in a little bit here. Is even for stony meteorites, like you're talking ordinary chondrites, you should still be getting about 1 to 2% nickel. There are some very rare chondrites, but again, if you're looking at an ordinary chondrite, 1 to 2% nickel in there. If you are assessing things that are iron meteorites, the nickel content that's average, like a normal range in iron meteorites, is 5 to 10%. There are meteorites that have lower nickel content. You'll catch some that are pretty much the extreme on the low side is about 4%. And you'll catch attack sites which have really high nickel content. So you're looking somewhere above 10% and up to 34% nickel content. And again, that's percentages. Because one of the other things you'll notice how the machines read is they'll read in parts per million and also read in percentages. And you got to be real
Yeah.
careful because sometimes it's hard to look at the numbers and tell which is which. But yeah, for irons, again, if you're below that 4% nickel, it's not. You know, if you're above the 34%, it's out of range.
Yeah, you have a note there also that you want to see chromium and manganese as well.
Yeah, so those are accessories, and like you heard in the video, Blaine was looking for chromium, and again, he said no chromium, boom, gone, it's out. You know, they definitely should be there for all the meteorites.
So I guess it kind of answers the question for us, like how many sampling spots do you need? Enough to make a decision. And so if you hit 1 and 2 and there's no chromium, move on. Good.
Yeah, you're probably not worth burning out the source, and just move on from it.
I threw this picture in here of our friend Daniel Shake, a classifier of meteorites, to show what they actually do use to juxtapose your point that they don't use XRF. So could you do me a favor and touch on what you see in the background if you're aware of it?
Yeah, so that's a scanning electron microscope, right? So again, that's going to use electron beam instead of X-ray in order to kind of be your source. And again, it allows you to get a visual map and also a chemical readout map of, again, not only what elements you're seeing, but how they are all put together. So you could tell which mineral it is for the exact thing. And again, you can move around and you're going to get a number of points, you know, and you can tell each point you're hitting there and tell exactly what's at each point as you read them. But again, same thing, you know, you're going to want to hit 20, 40 points in order to get accurate data.
Awesome. Thank you, man.
XRF, it can be a very useful tool if you had those two things we talked about. You have a machine that's capable and set in the right manner for reading mineral specimens, and two, a user or interpreter of that XRF data who has a background in what they're looking for in a big database for what the percentage ranges are for different types of meteorites. So again, it is a useful tool. It is not the know-all end-all. And again, if it was the know-all end-all, people would be classifying off of it. But the classifications are not based off of XRF or XRD data. And so again, add it to the arsenal. If you can get the right machine and the right person to read it, it definitely is very helpful. But don't stake the bank on it.
Yeah. I thought the last point on this page was pretty cool too, about, you know, what you find that shouldn't be there as well.
Yes, certainly. So again, if you get readings that are wildly out of the range of what should be in a meteorite, then you can basically rule out it being a meteorite. Again, things like copper have pretty specific ranges for the chondrites. You know, 80 to 280 parts ppm is where you should be hitting. So if you're hitting up in the percentages, right, you now have way too much, and you could basically rule out that being a meteorite.
Awesome. I appreciate your information as always. We have some actual FRF scan results. My bro from another Mo, Oz Backman, got these. So thank you very much for supplying them. It really helps our education and outreach and understanding, because I don't know what I'm looking at. Mike, can you tell us, is this good? Like, is this a lunar?
So let's take a quick look at what we got there. Again, Oz can speak to the data too. This is his stuff. So what I'm looking at here, just from a, hey, does this make sense? What elements do I have on here? Do I have anything crazy that's super high? Copper's there, but it's low, 77 ppm, right? That's safely within that range. We're not seeing percentages of copper. You got light elements in there, right? You got chlorine, you got potassium in there, right? Those are light elements that if this was the wrong machine set for metals, wouldn't be showing up. And this goes back to what we looked at. So all these readings on this page, right? Even though the column says ppm, if you look at like the sulfur, right? It's got a percentage sign next to the element in there. So that's actually telling you a percentage. Whereas like the K, potassium, 866.8, parts per million. No
Wow.
percentage sign next there, right? So again, you have to understand the machine and have an idea on how to read it. And then it's giving you the percent error on there beside a 2 sigma column. What do we got here? We got a decent amount of iron, good, and again, that's a percentage.
FE.
Nickel sitting at 1%, 1.08, 1.008 nickel Ni. So that's a good reading in there, right? That's more nickel than you find in earth rocks, right? So that's a good thing there. So yeah, it's, you know, this has readings in here that look decent, and nothing stands out as crazy. No super high titanium content, no super, you know,
We see
nothing in there. No gold.
we see chromium Cr in there. Is that what I'm seeing at 0.3?
Yeah, yeah, that's a chromium.
Okay.
Yep. So yeah, so this you know, to me these look like good readings. Again, I am not a world-renowned reader of these things. Again, it's just this is like the 101 level. Just, hey, you know, are the readings within par for what they should be? Hey, Oz, you want to tell them what that is?
It's an ordinary chondrite. It was one I actually bought from Matt Stream, and it was closer to a type 3H probably, or LH boundary, I guess.
And again, so it's not giving you a definitive answer. Is it an L? Is it an H? What petrology is it, right? It doesn't tell you any of that stuff, but it gives you the ball composition. And if you stay on this slide, Topher, this is great too, because it tells you up in the upper left-hand corner how long he ran that sample for, right? 132 seconds, a little over 130. So a little over 2 minutes of running the X-ray in order to get that set of data.
Pretty cool stuff.
Yeah. Thank you for letting us use all your samples, your test results.
Sure.
Yeah.
Anytime. I was
Yeah,
happy to help out.
This helps out tremendously, man. Really appreciate it. Mike, you have anything else you want to add to the conversation here?
No, I appreciate you asking me to talk about it. And like I said, it is a good tool. Again, they're expensive machines, but if you can find a source where you can get it done, it's a good indicator past just visual that you could use in making an assessment of, do I further want to take this and then turn it in for classification.
Exactly. All right. Hey, Mike, thank you very much for the education, the prepared education. Definitely appreciate it. Now let's see how good you are on your feet. We have some questions from our viewers. Okay, this is Stump Mike time.
It's doable.
Well, listen, I don't know if this is like a stumping type question. The computational part of my brain thinks if you have a lot of data where you have these XRF results and then you have, you know, human brains that have said, okay, this is what this actually is. Are there any like programmed or even AI type models that exist for aiding in interpretations of these results? Is that something that's being worked on somewhere? Is that just a horrible idea? I'm just curious your thoughts on it.
No, I don't honestly think that that's a horrible idea. I think AI has to come a long way as far as its weighting in what it interprets and puts weight behind within the data, in order for that to be useful. Case in point, I know someone put an interesting little thing up online of they had AI digest some results on a chondrite, right? And the interesting thing, and I asked specifically, what did you give it? Because at the very end of what they gave it, it had a breakdown of the classification and petrology associated with it. But AI kind of blew through it, and to the AI, you know, that the combination of alphanumerics for that didn't really mean anything to it, right? So I definitely think you could set up some programs, again, to simulate what the good analyzers for this data are doing and running through their process with a big enough bank of data to do it on. So I could see that happening in the future. I think the models have a long way to come, though.
Sounds good. Thank you.
I'm going to jump in and piggyback on that before we go to Pat. I heard that there's a great free tool out there called Google Lens. You take a picture of a rock, it tells you exactly what it's worth. Isn't that true?
Actually, that came up with somebody recently,
I
and
know.
I told them so far it's kind of the same thing with the AI and the interpreting the XRF and XRD results. As far as like like photography, like sending photos in. I've tried all the different like rock identification apps, Google Lens, everything. I've never really actually gotten a correct answer from any of them yet.
We use Google Lens a lot in Meteorite or MeteorWRONG, or well, I shouldn't say we use it. We get presented with those results a lot. And so far, it's been exactly perfectly 100% wrong.
Yeah.
I was like, I hope Pat's not going to contradict me, but I
No,
really doubt
no.
he's going to.
No, appreciate it. I think, Pat, you had a question as well, right?
Yeah. Mike, would you address the idea of XRF spot size, or the area that it averages over?
Oh, okay.
You got me stumped on that one, Pat. There are different things they do. So like XRD, they can rasterize the beam. So that's a kind of a hard question to answer because, like I said, rasterization is the same thing, almost like trying to fudge true bulk composition, right? So I'm going to break the beam up and I'm going to move it, and it's going to get me more of a bulk reading, for the amount of X-ray energy I'm putting into there. But yeah, I don't have the beam size down.
Okay, so that's one of the biggest factors in this. I don't know that there is a standard spot size, but I think it's on the order of a few millimeters, maybe 1 to 5 or so millimeters. One other thing, Michael, that we've been kind of using and kind of shooting from the hip on Meteorite or MeteorWRONG and the other identification pages is looking at the iron to nickel ratio. That's the most common one that I use when I'm attempting to interpret results.
I agree with that because those are two elements that I at least can recognize on these results, and they're two that are important for meteoritics. So, Mike, what kind of ratio would you be looking for? Could you add any comments on that?
Oh, you're talking in chondrites or you're talking in irons?
No, in chondrites, stonies.
So that's interesting because your content for your iron to nickel can vary a lot, whether you have a lot of sulfates in there, iron sulfides, troilite, things like that. So I don't have the numbers off the top of my head to do a ratio like that, and I have a feeling you're going to get a normalized range per type, right?
Mhm.
So something that's super high in sulfides, like your rumarudis, your enstatite chondrites, your enstatite chondrites. I think that those ratios there are going to have a lot different range than you would have in your H's through your LLs. So again, that goes back to having available a lot of specimens to
Yeah.
take samples of to get accurate ranging, which is how a lot of the folks who are very good at analyzing the data do it. That's their secret weapon, is that they have a large quiver of available specimens
Right.
to compare it to and create their own range banks.
Yeah, basically we got to get Blaine Reed to write the book.
I will also add a small comment on here because we're not going to give numbers of ratios, but you're going to want to see a lot less nickel than iron. And if you think that you have a piece of the moon and you're seeing 5% metal in it, think again. If you think you have anything that has, if you think that you have a non-iron meteorite that's coming in at 70% metals, that's slag. That's not a meteorite. Those are my Topher's rules of thumb for interpolating data. Does it qualify to take it to the next step? And there's so many steps between I found a rock and it's on a classifier's desk. That doesn't happen that way. And this is just another tool that can be used, but don't think it's the end all be all savior of the universe, because it's not. Thank you very much for watching, and I appreciate those who are subscribed. If you are subscribed and hit the notification bell on YouTube, you'll be notified when new videos hit. And one good thing about that is I'm putting out a lot of members only videos, but for the first like 12 to 20 hours, they're free for everyone. So if you stalk my channel online, you get to watch a few extra videos for free. If you're lazy, You have to pay as a member. I appreciate it. Guys, thanks a lot and have a great week. Take care.